This is the kind of question that sneaks up on you when the house finally goes quiet and the fridge hum sounds like the background music of the universe. Why is there something rather than nothing? Not a small question, not a polite one either. It kicks open the door, sits on your chest at 2:13 a.m, and asks you to explain, with a straight face, why reality bothered to show up at all. And because we're stubborn, because our species would rather argue with the night than close our eyes, we went looking for the first page of everything. The page we usually open is familiar, a story we half remember from school. 13.8 billion years ago, give or take the width of a hair on cosmic scales, the universe stepped onto the stage with a debut so intense we called it the Big Bang. Don't picture an explosion in pre-existing darkness. There was no empty room. The bang wasn't inside space, it was the creation of space. Time didn't tick before it. Before didn't even cache as a concept. That's the first disorienting trick. Someone moved the axes on the graph and forgot to tell us. From that white-hot beginning, everything you and I care about had its possibility minted. Space began to stretch like dough. Temperature fell from impossible to merely insane, and the primordial soup simmered itself towards structure. Energy condensed into particles. Particles gossiped into atoms. Atoms later conspired to become stars. Stars grew old and dramatic and scattered heavy elements like confetti. Those elements wandered into new clouds, new stars, new planets, and eventually into the quivering hand that's holding your phone. The big story is the same one your body tells. Hydrogen learned algebra and called itself human. If this were only a nice myth, we could clap and go to bed. But it behaves rudely like science, because the universe left receipts. Look at galaxies sprinting away from us, their light stretched, reddened, as space expands between everyone and everyone. That redshift isn't traffic leaving a city, it's the city blocks themselves sliding apart. Then there's the soft radio hiss filling the sky, the afterglow of the earliest light, the cosmic microwave background. It is the universe's baby photo, taken when it was a mere 380,000 years old. Newborn by cosmic standards, already glowing. Across the entire firmament, temperature differs by only tens of millionths of a degree. It's the most boring, beautiful wallpaper ever printed, and because it's so boring, so uniform, it tells us something profound about those first instants. Still, even this widely loved story has gaps as obvious as fingerprints on glass. The Big Bang model does a brilliant job with what happened after, but it freezes where our curiosity burns hottest, at the opening moment itself. Ask the equation, what caused the bang, and it looks away, pretending to admire the CMB. Mathematically, if we roll the film backward, density and temperature blow past very large to infinite, and the equations of general relativity, which normally behave like responsible adults, start flinging furniture. A singularity, we call it, less an explanation than a polite sign that reads, "We don't serve time zero here." Does that mean we abandon the trail? Hardly. It means we pace the boundary, press our ears to the wall, and listen for any echo of something on the other side. Even the standard picture, hot early universe, expanding space, light elements forged in the first minutes, arrives with little puzzles tucked beneath it like notes under a classroom desk. If distant regions of the sky were never in contact, why do they wear the same temperature so smugly? Why is space so astonishingly flat, as though the geometry teacher ironed every wrinkle? Where are the exotic relics some theories swear should be everywhere like cosmic Easter eggs? The Big Bang, powerful as it is, didn't erase our appetite, it sharpened it. But before we chase solutions, let's savour how outrageous the basic claim already is. We live in a universe where the vacuum isn't empty, where space expands without asking for permission, where the fossil light of the first epoch still bathes us with a whisper that has travelled for almost the entire age of everything. Think about that. The microwave background you could, in principle, pick up with a coat hanger antenna is older than any myth, than any mountain chain, than any star now shining. It is older than the Milky Way as a spiral. It remembers when clouds of plasma were the only weather. And then there's time. We talk about it like a river, steady and obliging, but near that beginning it behaves more like a language we haven't learned yet. Ask what happened before, and the question, as Stephen Hawking liked to tease, resembles asking what's north of the North Pole. It's a direction that exists grammatically but not physically. That doesn't mean inquiring minds should be quiet. It means we must be careful. The universe can break our grammar the way poetry does, not by being wrong, but by reaching further than the rules we started with. If you're feeling a little unsteady, good. We're close to the cliff's edge, and that's where the view gets interesting. Our plan in this series is simple in spirit and difficult in execution. We'll hold on to everything the standard model explains shockingly well, and then we'll follow the threads it leaves loose. We'll let the data bully the theory, not the other way around. When the background glow mutters a tiny asymmetry, when a telescope sees a galaxy that shouldn't be so grown up so early, we will not panic. We will make coffee. Then we'll ask whether the universe is telling us there was a chapter before chapter 1, or whether we've just misread a sentence in the prologue. For tonight, hold this picture. A universe that started hot and small, then cooled and blossomed. A sky filled with evidence old enough to make geologists blush, and a set of mysteries that refuse to be footnotes. If there's anything the Big Bang story teaches, it's that beginnings are complicated. Sometimes they're not single events but thresholds. Sometimes they aren't bangs at all, but transitions with histories of their own. And that suspicion that our beginning might itself have a beginning will pull us into the next hour. Because if the cosmos needed a way to smooth its early chaos, if it needed to set that wallpaper temperature so eerily uniform and iron out space like a bedsheet, then maybe there was a trick it used in the first fractions of a second. A trick wild enough to stretch a universe from subatomic to roomy almost instantly, and gentle enough to leave fingerprints we can still read on the sky. Let's talk about that trick. So here's the sleight of hand the universe may have pulled. Inflation. No, not the kind where your rent balloons faster than your paycheck, though, cosmically, it feels just as cruel. This inflation is the idea that, in the tiniest whisper of time after the Big Bang, less than a trillionth of a second, the universe blew itself up faster than the speed of light. Not like a bomb expanding into a room, but like the room itself stretching so violently that every speck of dust got flung out of sight from every other speck. Imagine baking bread dough and watching raisins in it sprint away as the dough itself puffs. Only this was less bakery, more pyrotechnic miracle. Why invent such a story? Because it answers those awkward questions we ended with. The horizon problem solved, because inflation squished the universe small enough before expansion that every patch could chat and agree on a uniform temperature before being yanked apart. The flatness problem smoothed out like a crumpled sheet pulled tight. Even the missing relics problem, those exotic monopoles and friends, get diluted away, scattered so thin across the stretched cosmos they practically ghosted us. Inflation isn't just clever math either, it left fingerprints. Those tiny quantum jitters, random energy hiccups bubbling in the vacuum, got magnified during inflation into the seeds of galaxies. Think about that. The reason we have spiral arms of stars, the Milky Way itself, is because the early universe amplified microscopic randomness into cosmic architecture. In other words, the cosmos is a giant improv artist. Took some quantum noise, said yes, and built the stage we live on. And then came the evidence. Decades later, telescopes like WMAP and Planck mapped the cosmic microwave background with ridiculous precision, and the tiny ripples in its temperature matched the statistical patterns inflation predicted. The theory hadn't just smoothed over philosophical headaches, it had forecast actual fingerprints that scientists could measure, like a criminal leaving the same odd shoe print at every scene. Cosmologists, for once, felt like detectives who'd actually cracked a case instead of inventing alibis. But let's pause. Inflation sounds like a magician's flourish. Solve all the problems, add some predictive power, bask in applause. And yet, true to human form, the applause is hesitant. Why? Because inflation doesn't get us entirely off the hook. It smooths, yes. It seeds galaxies, yes. But it doesn't really answer the original riddle. Why did inflation start? What set off this absurd expansion in the first place? Who wound the spring that let the universe uncoil? It's like hearing the neat ending of a bedtime story but realizing the first page is still missing. And then there's the nagging math. According to some theorems, courtesy of people like Borde, Guth and Vilenkin, even inflation itself can't run backward forever. It can't erase the need for a beginning. It just shoves the question a little further upstream. As if the universe is saying, sure, I'll let you peek behind curtain number 1. But don't ask what's behind curtain number 0. Still, don't underestimate how wild this chapter is. Think about what's being claimed. The uniformity of the night sky, the very existence of galaxies, the way you can even sit here and stream this video, all of it may trace back to a quantum hiccup, magnified by inflation into the scaffolding of everything. The cosy campfire of the Milky Way, the Andromeda Galaxy looming out there, clusters upon clusters of galaxies, cosmic cities sprawling in every direction, born from the smallest noise the universe could muster. And if you're wondering, why should I care about the universe ironing out its early wrinkles? Consider this. Without inflation, the sky might not look uniform, stars might not gather into the spirals we know, and your patch of universe might not have been hospitable enough for chemistry to dawdle into biology, then philosophy, then Wi-Fi. Inflation is not some nerdy fix. It's the reason your atoms have the time and space to ponder their own existence. But inflation comes with a tantalizing footnote. Some versions of the theory whisper that once it starts, it never really stops. Sure, it might pause locally, here in the bubble we call our universe. But elsewhere, beyond what we can see, inflation might still be roaring, spawning bubble after bubble, universe after universe, like cosmic champagne fizzing forever. That, my friends, is how you stumble from solving the flatness problem to sketching the multiverse. One small fix for a cosmologist, one infinite headache for philosophy. So we stand here, grateful and suspicious. Inflation gave us a cleaner story, but it also cracked open a much bigger one. Maybe our universe isn't the universe. Maybe it's just one bubble in an endless foam, each with its own script. And if that's true, then the Big Bang wasn't the bang, it was just our bang. Which leaves us staring at an even sharper question. What happens when you follow the story not to the first page, but to the bookcase itself? And here's where things get audacious. Because if inflation isn't the ultimate answer, maybe the universe didn't begin with a bang at all. Maybe it bounced. Picture the Big Bang again, but this time, reverse the film. Galaxies, stars, gas clouds, all collapsing inward like a movie rewinding. The sky grows hotter, denser, until everything crunches toward a single point. Now, instead of a singularity, the cosmic game over screen, imagine the universe does something cheeky. It bounces. Like a trampoline bending under too much weight and then hurling everything back upward, the cosmos might have collapsed, reached some extreme density, and then sprung outward into the expansion we now call the Big Bang. This is the essence of the Big Bounce idea. It's not a brand new thought. People as far back as the 1920s were already toying with it, and by the 1960s, cosmologists were openly debating whether the universe might be eternal, collapsing, rebounding, collapsing again like a cosmic accordion. In this view, our universe is not a one-time miracle, but just one verse in an infinite song. No true beginning, no awkward singularity, just endless cycles. And let's be honest, there's something deliciously comforting about that. The universe doesn't need a first cause, it's always been busy, pulsing in and out like a heartbeat. It even satisfies a kind of philosophical hunger. Many thinkers have argued it's easier to imagine an eternal cycle than a moment of absolute nothing suddenly becoming everything. Eternity, in a sense, is less shocking than creation out of nowhere. But, because you knew the but was coming, the bounce has issues. The most annoying is called the entropy problem. Every cycle of expansion and contraction should add more disorder, more cosmic clutter. If you play this out over infinite cycles, Entropy should build up like laundry in a student dorm until the universe is nothing but chaos. Yet here we are, in a relatively tidy, low-entropy cosmos where order exists, where galaxies form, and you can still eat pizza without it evaporating into maximum randomness. The bounce model struggles to explain how the universe resets the mess each time. Physicists have tried patching this with new tricks. Maybe, they say, during each cycle the universe expands so much that entropy gets diluted, spread so thin that the next cycle begins fresh again. Think of it as the universe airing out the room before starting another party. But the math is brutal. The second law of thermodynamics doesn't let entropy decrease, so every workaround feels like a loophole rather than a clean solution. Another snag? Einstein's general relativity doesn't allow for a natural bounce. Once the universe collapses to a singularity, relativity predicts it should just close up like a black hole. No rebound, no encore. For the bounce to work, you need new physics, something exotic to kick the cosmos back outward. Enter the quantum crowd. In the past couple of decades, researchers in loop quantum cosmology have suggested that when space itself is quantized, broken into tiny, discrete units at unimaginably small scales, gravity might flip from attractive to repulsive. At the brink of collapse, instead of pulling everything further inward, gravity could push back, preventing the singularity and triggering a rebound. It's as if the trampoline's fabric isn't smooth but woven from microscopic threads, and at high strain those threads push outward instead of snapping. This quantum bounce isn't just poetic speculation. It produces testable consequences. For example, it predicts subtle patterns, non-Gaussian features, in the cosmic microwave background that could in principle be measured. Some researchers have hunted for these fingerprints in the Planck satellite's data. So far, no smoking gun has appeared, but the search is ongoing. And then there's the boldest twist. If the bounce is real, our universe is the child of a previous one. Everything we see, stars, galaxies, our own existence, would be a legacy of a cosmos that collapsed before us. We are the rebound. Which raises a bizarre but thrilling question. If there was a before, what traces of it might still be written into our sky? The bounce model is messy, yes. It struggles with entropy, with relativity, with hard evidence. But it carries a philosophical elegance. It dares to say, maybe there was no bang at all. Just a rhythm of breathing, a cycle older than memory. And yet, some thinkers wanted to push it even further. They said, why stop at bouncing? What if the cycles themselves stretch across eternity, each one not identical but reshaping the rules slightly? What if the universe is not just rebounding but rehearsing? Cycles are seductive. They whisper to us that nothing ever really ends. Stars die. Their ashes seed new stars. Seasons repeat. Even our cells renew. So why not the universe itself? Why not a cosmic heartbeat? Bang, crunch, bounce, bang again. This line of thought gave birth to a family of models called cyclic cosmologies. Picture it. Expansion, our current universe, isn't forever. Someday, the pull of gravity, or maybe the mysterious dark energy, depending on its mood, could reverse the flow. Galaxies would stop racing outward, slow, then fall back together in a big crunch. The crunch would build, the universe would shrink, heat would rise, and at the brink, instead of collapsing to a lifeless point, it would rebound into another expansion. A new Big Bang. A new round of cosmic history. The idea has charm. It dodges the embarrassment of something from nothing. It grants us infinite time, infinite cycles, infinite chances for existence to stumble into being. In some versions, each cycle might even rewrite the laws of physics a little, experimenting with new recipes, different strengths of forces, different particle masses, different cosmic tunes. Ours just happens to be one in which chemistry stuck around long enough to invent espresso machines and TikTok. But like all charming ideas, cyclic cosmology hides complications. The biggest? Entropy, again. Every expansion and contraction would increase disorder. After billions of cycles, the universe should be a worn-out husk, not the neat low-entropy stage we observe. It's as if someone promised you an endless stack of pancakes but forgot that each one gets colder, soggier and less edible. By the 10th stack, you're just eating mush. Physicists have tried patching this. Some propose that during contraction, entropy gets diluted, spread thin across vast stretches, so the next bounce begins fresh. Others imagine that each cycle grows larger than the last, stretching entropy to insignificance. But these fixes often sound like cosmic accounting tricks, and the second law of thermodynamics keeps glaring at us from the corner, unimpressed. And then there's general relativity. Einstein's equations are party poopers here. According to them, once the universe collapses enough, it should seal itself off in a singularity. No bounce, no encore. Just a silent black wall. To get a true cycle, you need physics beyond Einstein. Something quantum, something exotic, something that flips gravity's sign when things get too extreme. Enter the quantum loophole. Some researchers argue that space and time aren't smooth at all, but granular, woven from tiny quanta, like pixels on a screen too fine for us to see. At the scales of a collapsing universe, these grains could resist compression, creating a repulsive effect. Instead of a singularity, you get a rebound. Instead of a wall, a trampoline. This is the realm of loop quantum cosmology, where the equations hint that a prior universe's death could spark our own birth. It's a wild thought. Everything around you, every star in the night, every atom in your blood, might be the recycled debris of a universe that came before. We are the aftershock of a previous cosmos. Still, evidence is slippery. The cosmic microwave background, the universe's baby photo, has been scanned for signs of a previous cycle, but so far nothing conclusive. Some claim to see faint rings or Hawking points that might hint at a before life. Others say the data is statistical noise. For now, the bounce remains a tantalizing story without a clean signature. But let's not dismiss it too quickly. After all, history is full of impossible ideas that became obvious once the right data arrived. Cycles resonate with human intuition. We've seen them everywhere else. The question is whether the universe itself is part of the pattern, or whether it hides a deeper, stranger rhythm we haven't guessed yet. Which brings us to one of the strangest contenders, a universe that doesn't just bounce or cycle but conforms, reshaping itself across unimaginable spans until what looks like an ending is actually a beginning. If the Big Bounce sounded daring, Sir Roger Penrose decided to go full jazz improvisation on cosmology. He called his idea conformal cyclic cosmology, or CCC for short. The name is a mouthful, but the image is hauntingly simple. The end of one universe is the beginning of the next. Here's how it works. Our universe, if left to run its course under current physics, is expected to end in what's called heat death. Galaxies drift apart, stars burn out, black holes evaporate into faint whispers of radiation. Eventually the cosmos becomes so stretched and cold that it's nearly featureless. No structure, no time markers, just a smooth ocean of emptiness. Entropy maxed out. Game over. But Penrose noticed something peculiar. If you have a universe with no particles carrying mass, no stars, no matter, only light and radiation, the distinction between big and small no longer matters. In physics terms, a scale loses meaning. You can stretch or shrink the equations and they describe the same physics. And here's the leap. If scale doesn't matter, then the end of one universe, the vast, smooth future, can be mathematically rescaled to look like the beginning of another. In Penrose's picture, the final state of one cosmos glides seamlessly into the Big Bang of the next. No bounce, no crunch, just an elegant handoff, a conformal match between death and birth. It's audacious, poetic, and let's be honest, weird. In this model, our Big Bang wasn't the first. It was just the latest reset, the opening chord of a new aeon. There may have been countless aeons before ours, and countless to come. Each one with its galaxies, its stars, its dramas. Entire histories forgotten except for faint scars in the sky. And here's where it gets juicy. Penrose predicted that the death throes of black holes in a prior aeon could leave imprints on our cosmic microwave background, specifically Hawking points, small circular hotspots where radiation from evaporating black holes seeped into the new universe. Think of them as bruises left by ancient giants, visible in the baby picture of our cosmos. His team even claimed to find some. Analyses of CMB data showed hints of unusual circles, patterns that don't fit random noise. For a moment it looked like the cosmos was whispering, yes, there was something before. Yes, your Big Bang had ancestors. The scientific community, of course, split in two. Some cosmologists leaned forward in their chairs. Finally, a testable signature of before the beginning. Others raised eyebrows, pointing out statistical flukes, biases in data handling, and the ever-annoying problem that extraordinary claims demand extraordinary evidence. As of now, CC sits in limbo. Daring, imaginative, plausible on paper, but waiting for confirmation in the sky. Still, Penrose's vision scratches an itch many of us feel. We are allergic to absolute beginnings. We like stories with context, with roots. An eternal chain of universes, each handing the baton to the next, feels strangely more natural than one cosmic spark out of literal nothing. CCC may not be the answer, but it embodies a truth about us. When the math stops, imagination takes the wheel, and CCC is just one branch of this growing tree of alternatives. Some models dream even bigger, moving beyond cycles altogether. They imagine higher dimensions, invisible to us, colliding in ways that create not just one universe, but potentially many. If Penrose offered us an elegant waltz of aeons, the next theory cranks the volume, tosses in an extra dimension, and says, what if universes are born from cosmic car crashes? Welcome to the brain crash universe, a theory that sounds like a comic book pitch but is actually one of the more serious contenders in modern cosmology. It's called the ekpyrotic model, from the Greek word for conflagration. Instead of a singularity or a bounce, it imagines our Big Bang as the result of two enormous sheets, called brains, slamming into each other in a higher dimensional space. Let me unpack that. In string theory, our universe might not be the whole show. It could be a three-dimensional surface, a brain, floating inside a higher dimensional bulk. Picture two flat sheets of paper drifting in a fourth dimension we can't perceive. When those sheets collide, the energy of impact doesn't produce a car crash, it produces a cosmos. Our cosmos. That collision in this view was the Big Bang. The fireball of matter and radiation wasn't born from nothing. It was sparked by geometry, by two brains brushing against each other after eons of silent drift. In fact, such collisions might happen again and again, meaning each bang is part of an infinite sequence of cosmic car crashes, one aeon after another, but this time orchestrated in higher dimensions. The appeal of the ekpyrotic model is that it sidesteps the singularity problem. No infinite density, no physics breakdown, just a very violent collision in a space we don't see. It also gives us a fresh take on the horizon and flatness puzzles. Before the collision, the brains could evolve for eons, ironing out irregularities before transferring their uniformity to the newborn universe. But, and this is a familiar refrain, the devil is in the details. The mathematics of brains and string theory is notoriously tricky, and critics argue the ekpyrotic scenario requires fine-tuning that may not be any better than the problems it tries to solve. Plus, evidence is hard to come by. We can't exactly peek into extra dimensions with a telescope. The only hope is that subtle patterns in the cosmic microwave background, like specific kinds of non-Gaussian ripples, might betray the fingerprints of a brain collision. So far, the CMB remains maddeningly quiet. Still, there's something intoxicating about this vision. Imagine our universe as just one of many brains in a vast higher dimensional bulk. Imagine countless collisions, countless big bangs, each birthing a cosmos with its own stars, galaxies, and physics. Suddenly the word universe feels too small, and it gets weirder. Some cosmologists suggest that if brains keep colliding, then the Big Bang isn't an event at all, it's a rhythm. A drumbeat in higher dimensional space pounding out cosmos after cosmos like a cosmic metronome. If you listen closely enough to the microwave background, maybe, just maybe, you can hear the faint echo of the last beat. Of course, when theories start sounding this audacious, skeptics sharpen their knives. Is this still physics, or are we drifting into science fiction with equations as props? That tension between imagination and rigour is part of what makes the story of the pre-Big Bang so compelling. Each theory carries the same ambition, to look past the curtain of time zero, and each one leaves us squinting at the same question: what counts as evidence when you're asking about the time before time, which leads us straight into the most fragile hunting ground of all, the cosmic microwave background. It is, after all, the universe's baby photo. If there are scars from a previous cosmos, or bruises from colliding brains, or whispers from a bounce, they'll be hiding in that faint static glow. Let's take another look at that wallpaper of the universe, the cosmic microwave background. At first glance, it's just a bland fuzz, uniform in every direction, like the world's most boring screensaver. But to cosmologists, this fuzz is a treasure map. Hidden in those tiny temperature ripples, differences of a few millionths of a degree might be the fingerprints of whatever came before our Big Bang. Start with the so-called anomalies. The Planck satellite, which mapped the CMB with exquisite precision, noticed oddities. One hemisphere of the sky seems a touch cooler than the other. And there's a puzzling cold spot in the southern hemisphere, a patch bigger and colder than randomness should allow. Some say it's just statistical noise, like seeing faces in clouds, but others whisper, what if it's a scar, a bruise left by a prior universe, or by a cosmic collision in the pre-bang landscape? The CMB is also where inflation flexes its muscles. Inflation predicts that those random quantum jitters blown up in the early universe should leave a very specific statistical pattern in the microwave background. And, amazingly, that's what we see. The ripples match inflation's predictions almost eerily well, as if the universe has been carrying Guth's notebook all along. But cosmologists want more. They hunt for something called B-mode polarization, a delicate swirl pattern in the CMB's light. Why? Because such a pattern could only be caused by primordial gravitational waves, ripples in space-time itself, generated during inflation's violent expansion. Detecting them would be like catching the echo of the universe's birth scream. In 2014, a team at the South Pole announced they had found it. Headlines exploded. First evidence of the Big Bang. Champagne bottles practically uncorked. But then, the crash. It turned out much of the signal came from ordinary galactic dust masquerading as primordial waves. The dream wasn't dead, but it was delayed. Since then, cosmologists have doubled down, building better detectors and planning missions like Lightbird and CMB-S4, hoping to sift through the dust and finally capture the real signal. If they succeed, it would be historic. Confirmation not only of inflation, but also of a violent prelude written into space-time itself. But here's the kicker. If they fail to find B-modes, that too would be explosive. It would force cosmologists back to the drawing board, reconsidering whether inflation, however neat, is really the whole story. And then there's the idea of non-Gaussianity, basically whether the CMB's ripples are perfectly random or show traces of something more structured. Inflation predicts a very particular kind of near-randomness. A bounce or a brain collision might produce a different statistical flavour. Think of it like analysing handwriting. The letters all spell universe, but the loops and strokes could tell you who wrote it. So far, the CMB is stingy with its secrets. Inflation looks good, but not perfect. B-modes are still hiding. Anomalies exist, but we don't know whether to treat them as cosmic gossip or serious clues. It's as though the universe gave us one photograph from its baby album, then smeared Vaseline over the lens. And yet, that's what makes the search addictive. Every new measurement feels like squinting harder at a blurred picture, hoping a sharper truth will emerge. Because if the CMB really does hold the scars of a bounce, or the bruises of colliding brains, or the echoes of previous aeons, then the Big Bang stops being the beginning. It becomes a page in a longer book, one we've only just started to crack open. And this is where cosmology meets detective fiction. The next clue doesn't come from the past, it comes from the future of observation. Telescopes that don't just capture light, but gravity itself. Cosmic archaeology at its boldest. Imagine this. Instead of looking at light, the usual messenger, we start listening to the universe's gravitational heartbeat. Because if anything could have pierced through the chaos of the earliest moments, it's gravitational waves, ripples in space-time itself. Unlike photons, which got trapped in that dense early plasma until 380,000 years after the bang, gravitational waves could travel freely, carrying gossip from the first split second. This is why cosmologists are obsessed with the idea of catching primordial gravitational waves. Not the ones we've already detected from colliding black holes or neutron stars. Those are cosmic fireworks, yes, but they're latecomers. What we're after here is the faint background hum left behind by the very birth of space. If inflation really happened, it should have generated a storm of these waves, stretching and squeezing space-time like a cosmic accordion. And the proof of that storm would be etched into the CMB's B-mode polarization, those subtle swirl patterns we talked about earlier. The stakes couldn't be higher. Detecting this signal would be like hearing the Big Bang shout. It would lock inflation into the textbooks as more than just an elegant patch. It would tell us, with direct evidence, that the universe once expanded faster than light in a fraction of a blink, and it would open the door to peeking beyond, because different models of inflation, bounces or brain collisions predict different fingerprints in those waves. But the search is brutal, the signal is faint and the cosmos is noisy. Dust in our own galaxy, magnetic interference, even instrument quirks, all of it drowns the whisper we're trying to hear. That's why new missions are gearing up. Lightbird from Japan, CMB-S4 in the US, and European projects too. Their goal? To stare at the sky with the patience of monks, filtering out every speck of dust until only the primordial hum remains. And here's the delicious irony. Failure is as exciting as success. If we don't find those gravitational waves, it could mean inflation didn't happen, or at least not the way we thought. Maybe the universe's early story was quieter, stranger, less explosive. Maybe a bounce or brain crash is waiting in the wings, smirking as inflation takes the blame. Meanwhile, gravitational waves aren't the only cosmic time machine. Astronomers are also chasing the 21-centimetre signal, a faint radio whisper from neutral hydrogen atoms before the first stars lit up. By mapping it, we could see the cosmic dark ages after the bang, and maybe spot anomalies hinting at exotic beginnings. It's as if the universe kept a diary in invisible ink, and we're finally learning how to shine the right light on it. All of this shows a truth about science at the edge. Sometimes the absence of evidence is just as thrilling as its discovery. If the universe stays stubbornly silent on gravitational waves, it doesn't close the case, it blows it wide open. It forces us to rethink, to ask whether inflation is the whole truth, or just a clever placeholder. And right when the field seemed locked in equations and microwave maps, along came a telescope that changed everything. The James Webb Space Telescope, our golden-eyed oracle, turned its gaze to the young cosmos, and what it saw was not what anyone expected. When the James Webb Space Telescope first opened its golden honeycomb eyes, scientists expected a graceful confirmation of our models, a pat on the back for cosmology. Instead, Webb pulled a classic move. It made everyone nervous. Because in those first deep images tucked just a few 100 million years after the Big Bang, Webb found galaxies that were way too big, way too soon. According to our playbook, it should take billions of years for galaxies to gather enough mass to rival the Milky Way. Yet there they were, massive, mature-looking systems already shining, while the universe was still rubbing the sleep out of its newborn eyes. Think of it this way. You show up at a kindergarten class and find half the kids already paying taxes and discussing mortgage rates. That's the level of confusion Webb dropped on cosmologists. The problem isn't just aesthetic, it's structural. Our standard cosmology says galaxies grow slowly, fed by the gravitational scaffolding of dark matter, nurtured by countless mergers over cosmic time. If galaxies could bulk up so quickly, maybe our models of dark matter behavior, star formation, or even the very timeline of the early universe need rethinking. Some researchers suggested we were simply underestimating the brightness of these galaxies. Maybe they weren't as massive as they looked, just packed with young, brilliant stars. Others argued Webb might be forcing us to admit that the early universe had shortcuts, ways of building structure faster than we thought possible. And then came the more radical whispers. Could this mean the Big Bang model itself needs patching? A few cosmologists, emboldened by the unexpected data, dusted off alternative theories. Perhaps the redshifts we're measuring, the stretching of light that tells us how far and how old things are, aren't entirely due to expansion. Maybe some of it comes from other effects, like photons losing energy along the way. This tired light idea had been tossed aside decades ago, but Webb's surprises gave it a brief second life in late-night seminars. Most cosmologists, though, aren't ready to burn the standard model over a handful of puzzling galaxies. The safer bet is that our simulations of the early cosmos need an update. Maybe the first stars formed faster, or black holes grew quicker, or dark matter clumped more efficiently than our equations assumed. Webb isn't killing the Big Bang, it's just complicating its childhood, and that's the beauty of it. Every telescope before Webb gave us more questions than answers, and Webb is simply continuing the tradition. Science thrives not on certainty, but on irritation, the kind of irritation that forces you back to the blackboard, muttering, "Well, that's odd." Still, the fact that one telescope could cause this much commotion should make us pause. If galaxies really were strutting around, fully formed just 300 of 500 million years after the bang, what else might be waiting to ambush our theories? Are we glimpsing cracks in the foundation, or just the messy fingerprints of a cosmos more resourceful than we thought? One thing's clear. Webb reminded us that the early universe wasn't a simple nursery. It was more like a wild frontier town. Galaxies sprouting out of the dust in record time, black holes gulping matter faster than our models allowed, structures appearing before the ink was dry on space-time itself. And if Webb can rattle cosmologists this hard, imagine what happens when we start comparing its findings with the cosmic microwave background. Because if the sky's oldest light says one thing, and the universe's first galaxies say another, then we may be staring at the outlines of a story stranger than inflation, bounces, or brain crashes alone could explain. The question becomes, is the Big Bang a neat beginning, or just the middle chapter of a saga where universes come and go, leaving faint scars in the sky? Science loves a plot twist, and Webb's discovery of oversized baby galaxies wasn't the only one. Cosmologists began whispering that maybe, just maybe, the universe is teasing us with inconsistencies, clues that the Big Bang as we picture it isn't the whole truth. Let's talk about an old rival that crept back into the conversation, the tired light hypothesis. It's a relic from the 1930s, when astronomer Fritz Zwicky suggested that maybe galaxies look redshifted, not because the universe is expanding, but because photons gradually lose energy as they travel across vast distances. Imagine light jogging across the cosmos and slowly running out of breath, arriving a little redder at the finish line. For decades, this idea was laughed off the stage. Why? Because it couldn't explain the cosmic microwave background, or the precise way supernova-like curves stretch with distance. Expansion simply fit the evidence better. But after Webb showed galaxies that seemed too mature for their age, some cosmologists cautiously cracked the door open again. Could photons be doing something subtle we've overlooked? Could the universe be playing a trick with time and distance? Don't get me wrong, the vast majority of scientists aren't throwing out the Big Bang. The tired light idea is like that one conspiracy theory uncle at the family reunion. Entertaining, occasionally provocative, but not something you base your life savings on. Still, the fact that it's even mentioned shows how rattled Webb left the room. Meanwhile, other alternatives have been polished up for a second look. Modified gravity theories, where the laws of gravity themselves shift under extreme conditions, have been floated to explain early galactic structures. Others toy with the idea that dark matter and dark energy, those mysterious placeholders we lean on so heavily, might be more dynamic than we assumed. Maybe they didn't sit quietly in the background. Maybe they partied hard in the early universe, pushing galaxies to grow up too fast. And then there's the deeper philosophical sting. Even if Webb's galaxies can be explained by tweaks to star formation models, the episode reminds us how fragile our settled science really is. Every time we think the narrative is nailed down, the cosmos slips us a new footnote. Reconsider this chapter. This isn't failure, it's the rhythm of cosmology. A century ago, the idea of an expanding universe was heresy. 50 years ago, the Big Bang wasn't yet consensus. Steady-state models still had loyal defenders. Now, inflation feels like gospel, but who knows? Webb might be the first domino nudging us toward another revolution. What's remarkable is that all these debates circle back to the same question. What happened at the beginning? Or was there even a beginning at all? Inflation, bounces, brains, multiverses, tired light. Each theory is an attempt to peek behind the curtain at T0, the place where equations break and imagination barges in. And if the universe is trickier than we thought, maybe that's the point. Maybe it doesn't want to give us a single neat origin story. Maybe it wants us to wrestle with multiple possibilities, each one stranger and more humbling than the last. Which brings us neatly to the multiverse, the wildest of all these ideas. Because if inflation can go on forever in some regions, spawning pocket universes like bubbles in a boiling pot, then our Big Bang wasn't unique, it was just local, a neighbourhood bang in an infinite, frothing landscape. All right, brace yourself. Because if inflation's math is correct, it doesn't just solve the neat puzzles of our own cosmos. It opens the door to something almost absurdly grand, the multiverse. Here's the logic. Inflation, once started, doesn't necessarily stop everywhere at once. In some regions, it fizzles out, creating a bubble of normal universe like ours, where expansion slows, matter forms, and stars eventually shine. But elsewhere, inflation just keeps roaring, stretching space faster than light, spawning more and more bubbles. Each bubble is its own universe, sealed off from the others by expanding space, like islands forever adrift in a stormy sea. This is the unsettling part. If inflation is right, then the cosmos is not a single story, but an endless anthology. Each bubble could have different physical laws, different strengths of gravity, different particle families, even different dimensions. In one bubble, stars never form. In another, chemistry never works. And in a rare few, conditions are just right for life to evolve and start recording late-night history videos on YouTube. That last point leads to what's called the anthropic principle. It's the slightly awkward argument that, out of countless possible universes, we naturally find ourselves in one that supports observers, because where else could we be? It's not a satisfying explanation in the way we usually like, but it does deflate the coincidence problem. The constants of nature look fine-tuned because we're inside one of the rare bubbles where they permit fine-tuning to be noticed. Of course, critics sharpen their knives here. The multiverse is notoriously hard, maybe impossible, to test. If other universes are forever sealed off by faster-than-light expansion, then what good is the theory? To some, it feels like cosmology wandering into metaphysics, a sprawling story that explains everything but predicts nothing. The physicist Peter Woit famously quipped that it's not even wrong, and yet, hints might still exist. Collisions between bubble universes, if they happened, could leave faint circular scars in the cosmic microwave background. Some teams have claimed to see possible imprints, though nothing definitive. Others argue that the statistics don't hold water. For now, the evidence remains frustratingly inconclusive, leaving the multiverse perched between science and speculation. But think about the sheer audacity here. If true, our universe is not the universe. It's just one bubble in an infinite froth, and every question we ask about origins might just be local trivia. Why does our cosmos look flat? Why does it have these constants, this chemistry, these galaxies? The answer might be as simple and as unsatisfying as, because that's what this bubble does. Still, even skeptics admit that the multiverse has a strange kind of elegance. Instead of bending over backward to explain why this universe has such suspiciously life-friendly properties, it shrugs and says, in infinity, every weird possibility happens somewhere. Our universe isn't special, It's just one roll of the cosmic dice. If that doesn't make your head spin, remember, the multiverse isn't the only contender. While inflation stretches space into endless bubbles, other theories imagine cycles, bounces, or higher dimensional collisions. Different routes, same destination. The Big Bang may not have been the absolute beginning, it might just be a local event in a much stranger, longer history. Which leaves us with a pressing question. If the Big Bang wasn't the first word, then what kind of book are we actually reading? Is it infinite pages, infinite cycles, infinite bubbles, or is there a deeper, single law that ties them all together? And to glimpse an answer, we'll need to return to where science feels most at home, the evidence. Because while the multiverse plays out in theory, our telescopes are still combing the sky for real, measurable traces of what happened before the bang. So far, our story has danced between dazzling theories, bounces, cycles, brains, multiverses. But science has a way of pulling us back down to Earth. Show me the evidence. And when it comes to the origin of everything, evidence means looking for the oldest fossils the universe left behind. The first and most famous fossil is the cosmic microwave background. But beyond that, researchers are now reaching for even subtler signals, hidden in the sky like faint fingerprints. One of the most promising, primordial gravitational waves, the ripples in space-time inflation should have unleashed. We talked about them before, but it's worth stressing. Their detection would be a Rosetta Stone for the early universe. They'd not only prove inflation happened, but also distinguish between rival models. Some bounces predict different wave patterns, some brain collisions leave distinct imprints. In principle, the universe has already written its diary in gravitational waves. We just need instruments sensitive enough to read it. Then there's the hunt for 21-centimeter radiation, the faint whisper of hydrogen atoms from the cosmic dark ages before the first stars. By mapping this radiation, we could trace how matter clumped together, perhaps even spotting odd patterns hinting at exotic beginnings. It's as if the universe left us an audio track to go with its visual album, and we're finally learning how to play it. Even the cosmic microwave background anomalies still tug at scientists' sleeves. The cold spot, the hemispherical asymmetry, are they just statistical quirks, or are they breadcrumbs pointing back to a pre-bang reality? Some theories predict precisely these kinds of scars if our universe once brushed against another bubble, or if it carried memory from a prior cycle. For now, it's unresolved. But the fact that these anomalies persist through different datasets keeps cosmologists awake at night. Meanwhile, the James Webb Space Telescope has added spice to the mix. Its discovery of surprisingly mature galaxies in the infant universe may not overthrow the Big Bang, but it hints that something in our early universe physics is off. Maybe star formation was faster, maybe dark matter behaved differently, or maybe our models are missing a deeper layer, something that connects these galaxies to what happened before the bang. And the future is only getting brighter. Japan's Light Bird satellite aims to measure the CMB's polarization with unprecedented precision. America's CMB-S4 project will push sensitivity to new heights. Together they could confirm or refute primordial gravitational waves within the next decade. On another front, enormous radio telescopes like the Square Kilometre Array will map hydrogen across cosmic time, offering an entirely new lens on structure formation. Here's the thrilling part. Each of these experiments has the power to either reinforce the standard picture or crack it open. A positive detection of primordial waves would lock inflation into the story forever. No detection, after instruments sensitive enough to rule it out, would be equally earth-shaking, forcing cosmologists to rethink the very script of the universe's origin. So while debates about brains, cycles, and multiverses feel like philosophy, the hunt is moving toward testable physics. Theories are narrowing, predictions are sharpening, and data is flooding in faster than ever, which leaves us in a suspenseful position. The universe has been coy, revealing just enough to keep us guessing. We've got the fossil light of the CMB, the growing gallery of early galaxies, the first whispers of gravitational waves, and anomalies that refuse to be ignored. Each clue points backward, toward the veil at Tiastazuara, and maybe beyond. And as we stare at that veil, we're forced to ask, What does it even mean to say the universe had a beginning? Is it a literal first moment? Or is beginning just the limit of our imagination, the point where our words and equations fall short? To explore that, we'll have to step not just into physics, but into philosophy, because at some point, the question isn't just what happened, but what do we even mean by happened? So here we are, staring at the wall called the beginning. The problem is, beginning might not mean what we think it does. We tend to imagine time as a long line, with a neat arrow pointing left toward the past. But what if that line itself is just a construct that only exists once the universe exists? Then asking what happened before the Big Bang might be like asking, what's north of the North Pole? It's a question that sounds grammatical but collapses under its own weight. Stephen Hawking once loved that analogy. He argued that time might be finite but without a boundary, like the surface of the Earth. You can walk north until you reach the pole, but beyond that, north is meaningless. In the same way, maybe time curves back on itself near the Big Bang. The start is not a wall but a smooth edge where the concept of before evaporates. Philosophers roll up their sleeves here. If time itself emerged with the universe, then the question, why is there something rather than nothing, becomes slipperier. There never was a state of nothing, because nothing presupposes a time for it to sit in. Instead, existence may simply be the default. Reality, by definition, is what there is. That doesn't stop the itch. Humans crave causes. We want to trace the spark to a lighter, the lighter to a hand, the hand to a person. When we hit the beginning, the causal chain abruptly cuts. For some, that screams of divine agency, a moment of creation. For others, it's an invitation to reimagine causality itself, to consider that not all truths have tidy reasons. Physics has its own philosophical rebels. Some theories propose that time isn't fundamental at all, but emergent. Like temperature, which only makes sense when billions of particles dance together, time might be a collective illusion arising from deeper, timeless laws. In that case, the Big Bang isn't the first moment, it's simply the point where time's mask slipped on. This perspective reframes everything. Instead of asking what happened before, the better question might be, what principles allow time and space to appear at all? Some physicists talk of the wave function of the universe, a quantum state from which space-time bubbles into being. Others speak of quantum tunneling from nothing, though in truth their nothing is not the absence of reality, but a deeper, rule-bound void humming with potential. It's unsettling but oddly liberating. If beginnings are an illusion, then the search for a clean first cause might be misguided. Maybe the universe is more like a story without a prologue, or a circle with no starting point. The hunger for a first spark might say more about our storytelling instincts than about the cosmos itself. And yet, even with these philosophical acrobatics, we keep looking. Because if we can't anchor ourselves in a clear origin, we at least want evidence that our models are telling the truth. Which is why the next phase of cosmology is less about abstract philosophy and more about sharper, bolder experiments, telescopes and detectors that could, within our lifetime, rewrite the opening of the universe's script. Let's shift our gaze from the philosophy of nothing back to the hardware of discovery, because the next few decades might be the most thrilling in cosmology's history. For the first time, we actually have the tools to test these outrageous ideas about what happened before the Big Bang. Start with the cosmic microwave background, our baby photo of the cosmos. Missions like Lightbird in Japan and CMBS-4 in the United States are being designed to measure its polarization with such precision that they might finally reveal the elusive B-mode patterns from primordial gravitational waves. If those swirls are detected, inflation graduates from elegant hypothesis to historic fact. If they're not, we might have to tear up entire chapters of the cosmology syllabus. Either way, it's a win for science. Next is the Square Kilometre Array, SKA, the world's largest radio telescope, now under construction across South Africa and Australia. Its job? To map hydrogen across billions of years of cosmic history, capturing the faint 21-centimetre signal from the universe's dark ages before the first stars flickered on. That's a whole era we've never seen directly. A missing act in the play. If inflation, bouncing universes, or brain collisions left scars in the way matter clumped, SKA could spot them. Then there's gravitational wave astronomy, which is just getting started. We've already detected black hole mergers with LIGO and Virgo, but future instruments like LISA, a space-based detector, aim to catch lower frequency waves, the kind that could carry whispers from the very early universe. Imagine hearing not just the chorus of colliding black holes, but the faint hum of space-time itself stretching in its infancy. Even particle physics has a role. Experiments at CERN and proposed future colliders are probing the properties of the Higgs boson and other particles that may have shaped the early universe. If new particles, or whole new forces, are discovered, they could provide the missing fuel for inflation or the bounce. And don't forget Webb. It's already rattled us with galaxies too big for their age, but that's just the appetizer. Over the next decade, Webb will map the early cosmos in exquisite detail, tracing the first stars, black holes and clusters. If the timeline keeps looking too fast, too early, then cosmology may need to admit its models are only the scaffolding of a deeper truth. Here's the astonishing part. All of these experiments are converging at once. By the 2030s, we'll have data from the CMB, hydrogen mapping, gravitational waves, and high redshift galaxies, all cross-checking each other. The odds that at least one of these will force a paradigm shift? Very high. So the suspense is real. In the next decade, we might confirm inflation, glimpse the scars of a bounce, or even see hints of a multiverse in statistical fingerprints. Or we might learn that time itself is stranger than all our current guesses. And this is where cosmology stops being just science and becomes story again. Because whether the Big Bang was the beginning or just a middle chapter, the search itself is a profoundly human endeavour. The refusal to accept that the horizon of knowledge is the end of the road. The universe may or may not have had a first page, but the fact that we're daring to look, that we're building machines to read its faintest handwriting, says everything about who we are. And yet, for all the telescopes and equations, we can't escape the philosophical dimension. Because even if science proves there were cycles or brains, or an endless froth of universes, the question will linger: why is there something rather than nothing at all? Here's the catch: no matter how sharp our telescopes get, no matter how deep our equations dig, we always run into the philosophical wall. Because even if we discover that the universe bounced, or cycled, or bubbled out of a multiverse froth, we still end up staring at the same haunting riddle. Why is there something rather than nothing? Physics can map the how, the choreography of energy and matter, the unfolding of space and time, but the why keeps slipping through our fingers. If the Big Bang was caused by inflation, then what caused inflation? If it was a bounce, what caused the bounce? If it was brains colliding, where did the brains come from? It's like peeling an onion that has no core. Every layer reveals another, but never the absolute beginning. Some thinkers embrace this endless regress. They argue that reality might simply be infinite, with no first cause. Just as asking, what's north of the North Pole is meaningless, maybe asking what happened before existence is equally nonsensical. Existence, they say, is the default. Non-existence isn't a real option. Others lean on the anthropic principle. Out of all possible realities, we live in the one that permits observers, not because it was designed for us, but because only in such a universe could creatures like us even ask the question. It's not a satisfying answer. It feels like being told, because you're here, that's why. But it has a brutal logic. Then there's the theological or metaphysical leap. The idea that the universe's origin requires an agency beyond physics, a prime mover outside of time and space. Many scientists avoid this move, not out of hostility, but because it sits outside testable science. Yet history shows us that for much of human culture, the notion of creation by a transcendent will has been the most intuitive answer. Meanwhile, physics itself keeps pushing boundaries where it starts sounding suspiciously philosophical. Quantum cosmology talks about tunneling from nothing, though their nothing is really a mathematical vacuum, humming with laws and possibilities. Other models treat the laws of physics as eternal, existing even when no universe does, ready to burst into form whenever the dice roll. Which begs another question. Where do the laws themselves come from? This is where cosmology turns into a mirror. The answers we prefer often reveal more about our human biases than about the universe. Some of us crave closure, a clear beginning, a spark, a first cause. Others crave eternity, an endless cycle that dodges the awkwardness of creation. And some are comfortable with mystery, content to say, the universe is, and that is enough. But whichever camp you lean toward, the remarkable fact remains. We live in an age where we can even have this conversation with data on the table. Not just myths, not just philosophy, but real sky maps, real galaxies, real gravitational waves. We're not guessing in the dark, we're arguing with evidence. So maybe the Big Bang wasn't the beginning. Maybe it was just a page in an infinite story, or maybe it was the first and only spark. Either way, what matters is that we're daring to ask, and daring to listen for answers written in the faintest whispers of light and gravity. And here's the kicker. Whatever the truth is, it will be stranger than any story we've told so far. Stranger than multiverses, stranger than bounces, stranger than brain crashes. Because the universe has never once settled for being ordinary, which leaves us once again with the night sky. Those stars above your head, they are fossils of 13.8 billion years of history, glowing reminders that you're part of a story that started long before you and may stretch far beyond. And with that, we close this chapter. But don't mistake close for end, because in cosmology, every answer is just another question dressed up in better data. The adventure continues, as it always has, as it always will. Let's linger on that thought. Every answer is just another question in disguise. Because if cosmology has taught us anything, it's that the universe refuses to hand us a neat final chapter. Instead, it gives us a library of drafts, each one scratched out by new data, each one rewritten when the sky surprises us again. Think back. 100 years ago, we didn't even know the universe was expanding. Many astronomers thought the Milky Way was the entire cosmos. Then Hubble, peering through his telescope, revealed galaxies rushing away like sparks from a firework. The static cosmos model died overnight. Fast forward. The discovery of the cosmic microwave background in 1965 confirmed the Big Bang and buried the steady-state theory. Each time we thought we'd nailed the truth, the universe dropped a twist in our lap. And today, inflation looks strong, but still unproven. The multiverse is tantalizing, but slippery. The bounce is elegant, but starved of evidence. Brain collisions are bold, but speculative. Even our standard Big Bang model, though wildly successful, keeps coughing up anomalies. Mature galaxies too soon, background patterns too odd, mysteries about dark matter and dark energy that make up 95% of reality, yet remain invisible. This isn't failure. This is how science grows. Knowledge isn't a fortress we build once. It's scaffolding we keep adjusting as the structure stretches higher. Every wrong model was a step that got us closer to the current one, and every current model will one day be a museum piece. Future generations will look back at our cosmology the way we look at medieval maps, charming, ambitious, but incomplete. Here's the humbling part. We might never get the final answer. Maybe the human brain, wired for survival on one small planet, simply can't hold the full truth of the cosmos. Maybe the real laws are so alien to our intuition that even if written down, they'd read like nonsense. And yet, we keep trying, because that's what humans do. We build stories, models, metaphors, all in the hope of getting a little closer to the heart of reality. And in the process, we get something unexpected, not certainty, but wonder. The wonder of standing under a sky that is both familiar and incomprehensible. The wonder of knowing that the atoms in our bodies were forged in stars, and that those stars were seeded by ripples from the universe's first instance. The wonder of realizing that, in asking these impossible questions, we are the universe contemplating itself. So where does this leave us? not with answers carved in stone, but with a question still burning. Was the Big Bang the beginning, or just one moment in an eternal story? The data we gather in the next decades may sharpen our picture, may even point us to one theory over another. But the mystery will never fully vanish, because the cosmos isn't just a problem to solve, it's a horizon that keeps receding as we walk toward it. And maybe that's the true gift. The point isn't to finish the story. The point is that the story pulls us forward, always searching, always wondering, always daring to look beyond the edge of what we know. So tonight, when you glance up at the stars, remember, you're not just looking at ancient light. You're looking at the residue of a mystery still unsolved. A mystery that may never resolve into a single tidy answer. And maybe that's okay. Because sometimes, the beauty of the universe lies not in being explained, but in being endlessly explored. Maybe that's the true secret. The universe isn't a riddle to be solved once and for all, it's a conversation. A long, messy, thrilling dialogue between reality and the creatures who dare to question it. Every telescope we build, every equation scribbled on a chalkboard, every late-night debate between physicists is part of this back and forth. The cosmos speaks in photons and gravitational waves. We respond with models, metaphors, and sometimes wild guesses. And when the universe inevitably proves us wrong, it isn't shutting us down, it's inviting us to ask better questions. Look at how far that conversation has carried us. In just a century, we went from thinking the Milky Way was the entire cosmos to realizing it's a tiny suburb in a sprawling galactic metropolis. We went from imagining a steady, eternal universe to discovering it had a fiery birth. We went from Newton's clockwork heavens to Einstein's pliable space-time to quantum physics' jittery probabilities. Each shift wasn't just a new answer. It was a new way of asking what it means to exist at all. And here's the part we often forget. This story isn't about equations alone. It's about us. The fact that human beings made of star stuff can turn our gaze back on the stars and wonder how they began, that's astonishing. It means consciousness itself has become a tool of cosmology. The universe has grown eyes, and it's using them to peer at its own origins. That's why these questions matter, even if they never find closure. Asking what happened before the Big Bang, or whether there was a before at all, isn't just physics. It's an act of belonging. It's how we claim our place in the cosmic narrative. So the next time someone tells you these ideas are too abstract, too speculative, too far from practical life, remember this. The search for beginnings is woven into who we are. From ancient myths to modern telescopes, humanity has always yearned to know not just where we are, but when we are, and what story we're part of. Maybe one day telescopes will confirm inflation's ripples. Maybe they'll find scars from a bounce. Maybe they'll hint at other universes, or maybe they'll force us to accept that the beginning is a horizon we'll never cross. But whatever the outcome, the act of searching transforms us. It humbles us, binds us together, and reminds us that, for all our struggles and divisions down here on Earth, we share one sky. And that sky is older, deeper, and stranger than any of us can fully grasp. So, was the Big Bang the beginning, or just a chapter? The truth is, we don't know. But the not knowing is exactly what makes the journey worthwhile. There's a beautiful irony in all this. The more we learn about the universe, the more we realize how little we know. Each breakthrough, each satellite launched, each telescope calibrated doesn't close the book. It just opens another chapter. And maybe that's the real engine of cosmology. Curiosity as an endless fuel supply. Think about the pattern. The discovery of the universe's expansion didn't end the debate. It triggered new ones about its fate. The detection of the cosmic microwave background didn't solve the puzzle. It raised questions about initial conditions. Inflation answered old problems but invented new ones. Webb has shown us galaxies that grow too fast, black holes that bulk up too early, stars that appear before the cosmic timeline gives them permission. Every answer is a doorway, every discovery a cliffhanger. And in that sense, cosmology is less about solving and more about living with mystery. Our ancestors told stories about cosmic eggs, world trees, gods breathing out existence. We tell stories about singularities, inflation, quantum tunneling, and multiverses. Different costumes, same impulse, to place ourselves inside a narrative bigger than ourselves. The real wonder is that our modern stories are testable. We can point satellites at the sky, build detectors that listen to space-time itself, and check whether our cosmic myths align with reality. When they don't, we revise them. That willingness to be wrong is what separates today's cosmology from yesterday's myth. But don't underestimate the poetry still hiding in the equations. When you learn that the uniform glow of the microwave background is a whisper from 13.8 billion years ago, or that your atoms were minted in the cores of long-dead stars, or that gravitational waves can carry us news from black holes colliding a billion light-years away, that's not just physics, that's intimacy with the cosmos. And here's the kicker. Even if we never pin down the absolute beginning, we've already gained something extraordinary. We've learned that the universe is knowable, not fully, not finally, but enough to sketch its history, to see its scars, to glimpse its youth. We've turned the night sky from a ceiling of mystery into a record of events. So maybe the question, was the Big Bang the beginning, isn't meant to have a final answer. Maybe it's meant to keep us moving, to keep us curious. The value isn't in the conclusion, but in the act of chasing it. Because one day, long after we're gone, other beings, human or otherwise, will still be staring at the sky, asking their own questions, revising their own models, marvelling at how deep the mystery goes. And that might be the real cosmic story, not beginnings or endings, but the endless dance of curiosity itself. And maybe that's the most human thing about cosmology. Not the math, not the telescopes, but the restlessness. We can't stop asking. Even when the answers slip further away, we keep building bigger machines, drawing wilder theories and staying up too late arguing about infinities. It's almost as if the universe planted this itch inside us, the need to understand itself, using us as its messengers. Think about it. 13.8 billion years after the supposed Big Bang, a species of upright apes crawls out of Africa, invents language, and eventually builds machines that can see the afterglow of creation. That's absurd. That's miraculous. It's also deeply funny, because here we are, cosmic latecomers trying to reconstruct Act 1 of a play that's been running long before we found our seats. And here's the twist. No matter what we find, the story will always stay unfinished. If we confirm inflation, we'll immediately want to know what lit the fuse of inflation. If we prove a bounce, we'll demand to know what the universe bounced from. If we glimpse signs of other universes, we'll ask what contains the multiverse itself. It's an infinite regress, a hall of mirrors that dares us to keep walking, but maybe that's the point. Maybe the universe isn't designed to give us closure, it's designed to give us awe. We don't look at the stars to finish the story, we look at them to feel the story. To be reminded that life isn't just bills and deadlines and politics, it's also questions so enormous they make your spine tingle. And if the Big Bang wasn't the beginning, so what? The fact that we can even phrase the question means we're playing a game no other known species has attempted. Ants don't ask about multiverses. Dolphins don't puzzle over cosmic entropy. We do. And in doing so, we've turned existence itself into a detective novel, where every chapter ends with a cliffhanger. So tonight, when you see the stars, don't just admire them. Think of them as invitations. Each one is a postcard from the past, stamped with mysteries still unsolved. Each one is saying, keep going, you're not done yet. Because the universe may or may not have had a beginning, but our story with it has only just begun. Here's the truth we circle back to again and again. The beginning might be unknowable, and yet that doesn't make the search pointless. It makes it profound. Think of it like this. You're standing on the edge of a vast ocean at night. You can't see its far shore. You can't measure its full depth, but you throw pebbles into the dark, listening for echoes, watching for ripples. Each pebble is a telescope, a detector, an equation scribbled by a physicist who can't stop wondering, and slowly patterns emerge. We might never drain the ocean, but we learn its rhythms, its tides, its storms. That's where we are with cosmology. We may never peel back the absolute first moment, but with each observation, the microwave background, primordial waves, Webb's galaxies, hydrogen's faint whispers, we sketch the shoreline of mystery a little more clearly. And that, in itself, is astonishing. Because this universe didn't owe us an explanation. It could have been forever silent, indifferent to our curiosity. Instead, it left clues. Fossil light, rippling space-time, galaxies that tell their age through redshift. The cosmos is inscrutable, yes, but not mute. What's more, the very act of asking reshapes us. Whether you lean toward God, multiverses, or eternal cycles, you're joining a lineage of humans who refuse to stop at the obvious. Farmers who charted stars to mark the seasons, priests who told myths of creation, astronomers who ground glass into lenses, physicists who wrote equations on blackboards in chalk-stained rooms. All of them reaching, all of them trying to trace the spark back to its source. And here we are, the inheritors of their wonder, looking up at the same sky. The difference is, we now know those stars are nuclear furnaces billions of light years away, and that their light began its journey long before humanity even existed. We're not just looking at the night sky, we're looking into time. So, did the Big Bang mark the true beginning? Or was it only one note in an eternal symphony? Maybe we'll never know. Maybe the answer lies forever beyond our reach. But the act of asking, that's where the magic lives. That's what keeps us awake, staring into the dark, listening for whispers from the universe. Because in the end, the question of beginnings is less about physics and more about what it means to be human, small, finite creatures who cannot stop chasing the infinite. And so, we circle back to where we began, standing at the threshold of the Big Bang, squinting into the dark beyond it. The data brings us close, the theories push us further, but the final curtain never quite lifts. And maybe that's exactly how the cosmos intended it. Because beginnings, as humans imagine them, are neat. A first page, a clean prologue, a spark from nothing. But the universe has never cared about our need for neatness. It sprawls, it surprises, it refuses to sit politely inside our categories. We want a tidy sentence. In the beginning, there was, but what if the universe is more like a poem? Open-ended, layered, impossible to pin down. Think of the irony. The same species that loses its keys and forgets birthdays is here, on a tiny blue dot, arguing about the preconditions of space-time. Our lives are so fleeting, yet our questions stretch beyond eternity. We're creatures of dust daring to interrogate infinity. That's not just science, it's audacity. And here's where it gets personal. Every one of us carries the Big Bang inside us. The hydrogen in your body was forged in that primordial fireball. The calcium in your bones was cooked in the hearts of stars that lived and died billions of years ago. The iron in your blood was hammered out in supernova explosions. You're not just asking about the beginning, you are the beginning given form and consciousness. That's why this story matters. It's not abstract, it's intimate. When we wonder whether the Big Bang was the true start or just a chapter in a longer epic, we're not just asking about galaxies, we're asking about ourselves. Are we a one-time accident, or part of an eternal cycle? Are we children of a singular event, or citizens of a multiverse teeming with alternate possibilities? Science won't answer those questions tomorrow, maybe not ever, but that's okay. Because the real gift isn't the answer, it's the perspective. The reminder that in the face of bills, routines, and trivial worries, we're participants in something unimaginably vast, that we carry stardust in our veins, that we belong to a cosmos that keeps us guessing, keeps us humble, keeps us in awe. So tonight, when you step outside and look up, let yourself feel it, the quiet pull of mystery, the hum of something bigger. The knowledge that the same light hitting your eyes has travelled billions of years to greet you, that you're not just a spectator, you're woven into the story the universe is still writing, and maybe, just maybe, that's the only beginning we need. Maybe that's the quiet brilliance of cosmology, It never really ends. The search for a beginning doesn't just describe the universe, it describes us. Our hunger for origins, our obsession with causes, our refusal to accept that some doors may stay closed. Look at our history. Thousands of years ago, we told myths of God sculpting the cosmos from clay, or pulling the world from an ocean of chaos. Today we trade those myths for equations about inflation, brains, and quantum foam. But the heartbeat is the same. Humans demanding to know, how did this all start? And yet, maybe the deeper truth is that the universe is less like a book with a first page and more like a song. You can ask, where does the song begin? But the melody doesn't care. It loops, it echoes, it blends into silence and re-emerges. The origin isn't a single note, it's the music itself. Physics hints at this. Cyclic models, eternal inflation, multiverses. These are all ways of saying the cosmos might not have a sharp start or finish, only rhythms. Even the Big Bang, for all its drama, could be just one crescendo in a large composition. But what makes this thrilling is that we don't just watch the song, we're inside it. Every atom in your body vibrates with echoes from that cosmic melody. You're not just asking about the beginning, you're singing it every time you breathe, every time your heart beats. So perhaps the answer isn't whether the Big Bang was the first event. Perhaps the answer is simpler, stranger, and more human. The beginning is wherever we choose to start telling the story. For some, that's the singularity. For others, it's the cycle before. For others still, it's the moment consciousness awoke on a small blue planet and asked the question for the first time. And that means you, sitting here, listening to this, are part of the beginning too. Because the act of wondering is itself a kind of creation. The universe doesn't just exist out there, it also exists in here, in the human urge to make sense of it. So, was the Big Bang the beginning? Maybe, maybe not. But the fact that we can stand in the dark, look up at the stars and dare to ask, that's the real miracle, and maybe that's the secret ending we never expected. The universe's beginning isn't just a scientific puzzle, it's a mirror. When we stare into the question, what we really see is ourselves. Because think about it, if tomorrow scientists announced with absolute certainty that the Big Bang was the first and only beginning, would that stop us from asking? No, we'd immediately demand, why that beginning? Why that moment? Those laws, those constants? And if they announced instead that the universe has no beginning, that it stretches back eternally in cycles or multiverses, would that stop us? Of course not. We'd just pivot to, why does eternal existence exist at all? The point isn't that the question has no answer. The point is that the question is designed to be endless. It's the spark that keeps humanity restless, inventive, reaching. It fuels philosophy, religion, science, art. It's the engine behind every story we've ever told. And here's the wild part. Maybe the universe doesn't mind. Maybe it built us precisely to keep asking, to keep echoing its mysteries back to itself. We're stardust that learned to doubt. Matter that became self-aware enough to interrogate its own origins. We are the Big Bang looking in the mirror, trying to remember how it all began. So when you lie awake at night staring at the ceiling, wondering if you'll ever know the truth, realize you're already part of it. Your brain firing in the dark, your heartbeat steady, your curiosity alive. That is the continuation of the cosmic story. The universe didn't just begin once, in a flash of fire. It begins again every time a human being dares to ask, where did it all come from? And that perhaps is the most sleepless historian answer of them all. The beginning isn't buried in the past. The beginning is now. Here's the punchline. Maybe the most important thing about the universe's beginning is that we'll never settle it. And that's not a tragedy. It's the invitation. The mystery is the feature, not the bug. Because if you think about it, what would a final answer even look like? Imagine tomorrow NASA holds a press conference and declares, we've confirmed it. Time began exactly here, in this event, at this fraction of a second. Would that really satisfy us? Or would it just feel like someone closed the book mid-sentence? Humans are funny that way. We don't actually thrive on closure. We thrive on wonder. That's why every culture, from the Babylonians to the Maya to Einstein's generation, built its own origin story. Not because one was right and the other's wrong, but because the act of telling them is how we locate ourselves in the cosmos. And here's the cosmic irony. The more advanced our science becomes, the more our stories start sounding like myth again. Cyclic universes echo ancient Hindu cosmologies. Multiverses rhyme with medieval Islamic debates about infinite worlds. Even the idea of something from nothing feels like Genesis, retranslated into equations. Different languages, same hunger. That should humble us. It should also make us laugh. Because it means we haven't outgrown our ancestors. We've just given their questions shinier tools. The torch they carried into the darkness is the same one we hold now, just shaped like a telescope or a particle accelerator. So maybe the point of the Big Bang debate isn't to nail down a single answer, but to keep the torch lit. To remind ourselves that we're part of a story older and stranger than anything else we do between 9 and 5. That even when the rent's due, or the inbox is overflowing, there's still a part of us staring at the night sky, asking questions with no end. And that's the real beginning. Not the fireball, not the equations, but the asking itself. Because as long as someone, somewhere, keeps wondering where it all started, the story of the universe never really stops. And so, let's end where the universe began, or refuse to begin, depending on which theory you prefer. Because after all these cycles, brains, bubbles, inflations, and poetic nothings, one truth remains unshakable. We are creatures who cannot stop asking. Think of the sheer audacity of that. A universe that could have remained silent instead produced beings made of its dust who look back at it and demand, "Explain yourself." That alone feels like a kind of miracle. Maybe the Big Bang was the beginning. Maybe it was just the middle of a longer cycle. Maybe we live in one bubble of an infinite foam. Maybe the laws of physics themselves are accidents of a deeper reality we'll never touch. Each possibility is staggering, each one worth losing sleep over, but whichever door the truth hides behind, the act of chasing it matters more than the answer. Because when we chase the universe's beginning, what we're really doing is practicing humility. We're acknowledging that we are small, brief, fragile, and yet capable of questions that stretch beyond galaxies. And that's why this story doesn't really close. The ending of one cosmological model is just the prologue to another. One generation's final answer is the next generation's laughable error. The journey never resolves, and that's the beauty. So the next time you hear about scientists arguing over inflation, or quantum foam, or whether the multiverse is science or fantasy, don't roll your eyes. Smile. Because what you're witnessing is humanity's oldest ritual, sitting around the fire, whether of wood or plasma screens or starlight, and telling stories about where it all began. And maybe that's the real Big Bang. Not a singularity of matter and energy, but the explosion of curiosity inside fragile human minds. An ignition that keeps burning. Billions of years later, every time we dare to look up and whisper, "How did it all start?" That's not just science. That's us,